Good morning slash afternoon slash evening, everybody, regardless of where you are. My name is Aaron Stannard, and I'm here with my teammate, Gregorius Sodharmo. Gregorius,
Hello.
how are you doing today?
Oh, pretty good. Finally, get that sickness out of my system, so I'm feeling
That's
great.
Yeah, that's right. I had to do all the speaking for you during our August community stand up. I had totally forgotten about that. Well, welcome everybody to our September 2024 Akka.net community stand up. We've got a bunch of little bits and pieces to go through here today, and we're excited to go ahead and get to all of it. So, the first thing I'm going to go ahead and drill into real quick is actually some marketing stuff that we've been working on. All right, let me scroll down here. We shipped a couple of videos this month. I did a quick one on head of line blocking explained. This is going to feature really heavily, by the way, in some of our plans for Akka.net 1.6. The biggest performance issue that Akka.Remote has right now is head of line blocking. That is a problem with TCP itself. It's not how we're using it. It is basically an issue that is inherent to TCP's sort of philosophy of how reliable delivery is supposed to work. And by the way, this is also a infamous problem with HTTP as well. HTTP 3, which is built on Quick and not TCP, is being essentially delivered as such in order to avoid this exact problem. So headline blocking is something that is a bit of a pervasive issue in our internet connected world, largely as a function of basically how TCP works. Anyway, you should watch the video to kind of learn a little bit more about that. But I kind of made this video as a setup for our bigger one that we released about a week ago, maybe 10 days ago. Part 2 of our Turbo MQTT series, which focuses on how we use System.Memory and Akka.Streams to be able to do high-speed packet parsing. So I mentioned basically in our video there that Turbo MQTT itself is susceptible to head-of-line blocking because 99.999% of all MQTT brokers require TCP in order to work. There are some that use Quick, but they're on the fringes of kind of what's acceptable in the MQTT ecosystem. So overwhelmingly, they're all vulnerable to this same type of headline blocking problem. So one of the things we have to do, and we've already done this pretty well in Akka.Remote, but one of the things that we have to do in Turbo MQTT to try to reduce how much impact headline blocking might have on our system is because packets are all transmitted and received in their original transmission order. That's another TCP enforced requirement there. We need to guarantee that our ability to process those packets on the outbound and inbound sides of the pipeline is as fast as possible. Our goal is basically to make sure that the IO system is the bottleneck, not our application code and not our certainly not our library code. So we talk about how we designed our packet parsing system to be as quick as possible using System.Memory, the memory pool, a lot of work with spans. And then generally we use a technique called bit banging, which is basically kind of like emulating signal processing with software, more or less, where you're kind of consuming a buffer of bytes and doing stuff with it, kind of like picking up signals as you kind of iterate over it. So we did all that. We also did our Phobos webinar, basically since our last community stand-up. So this is all about how to actually use Akka.net and Phobos and Seek and a number of other different tools for diagnosing real Akka.net problems. That should be going up on the YouTube channel any day now, I think. So we should have that up shortly. So that kind of is our wrap for our marketing summary. We haven't really done a blog post in a little while. That's my fault. I've had lots of other irons in the fire, so to speak, lately, but we are planning on writing a few more before the end of the year. Now, next, we should go ahead and dive into our actual Akka.net releases here. And we have a bunch of them. We actually did a pretty big Akka.net update that covers a assortment of important bug fixes. And these bug fixes kind of got sprinkled over pretty much every major library in the Akka.net ecosystem. So, Gregorius, I'm going to have you take it away and start by talking a bit about Alpakka 1.5.28, since we haven't updated that library in a little while.
Yeah, I think the last time we updated was 5.15, which is quite a long time ago. But anyway, yeah, in this release, we of course bumped the Akka version to 1.5.28, and then there's a fix on Streams Event Hub version 5, which fixes a concurrent processing bug. The old code could not handle concurrent uh, process event from the process client, and we fixed that.
And we're in the process right now of basically consolidating the Event Hub integrations in Alpakka. We're going to condense it all
Hmm.
down to a single package. So that's being done. Let's see. Akka.Persistence.Sql. We had a big third-party contribution here that we
Hmm.
merged in.
Yep.
So this user contributed basically the data options type from Link2DB, which is basically a way we can do things like passively provide credentials to an underlying database. So if you want to use something like, and correct me if I'm wrong, Gregorius, if you want to use something like implicit Azure AD identity to go and authenticate against a database, this is how you would do it in Link2DB, right?
That is correct. It's more than just credential. It's basically passing in a connection factory to link to DB. So we're not limited just to the connection string anymore.
Yeah. So this is kind of designed to facilitate, things like implicit authorization and authentication, all that good stuff. So this will support all of that. I know, Gregorius, you had to do a little bit of feng shuang to make this work, and you also documented all of it. So
Hmm.
this has been deployed as part of 1.5.28, if I'm not mistaken.
Yep.
And I believe the documentation for this stuff is, let's see,
It's the easy way. Yeah, that one.
Akka hosting.
It
Yeah, there we go. Yeah, here we go. Here's the new data options setup right here. So you do talk us through how to document it. In theory, you can use Hocon to go ahead and do this. It requires Hocon plus a setup class, which is what Akka Hosting is actually using under the covers here. But we are not super key. You should just move off of that and use Akka Hosting, please. So that's our kind of take on that. We've also been fixing these. You're in the process of working on this for Akka.Persistence Azure right now, Gregorius, but fixing these bugs related to saving multiple snapshots taken at the same sequence number.
That's related to the Akka persistence changes down below that we'll talk about later.
Yeah, so this is kind of a pervasive change. So we've been on a roll with our past couple of releases of finding like 10-year-old bugs and fixing them. This is another 10-year-old bug that we discovered, which is that snapshots have basically never been saved in any of the SQL-based persistence mechanisms using a correct timestamp ever, apparently. Um, so we're in the process of fixing that. Let's see. Akka hosting 1.5.28. So we upgraded to Akka.NET 1.5.28, obviously. But one of the things that I added is now we reference Akka.Streams in here, and we automatically inject a reference to it inside Akka hosting. Basically, that way we had a user who was trying to do stream refs, which is something that we covered in our video that we did earlier this year about Spectre.console integration with Akka.NET. Stream refs basically allow you to kind of make Akka streams graphs that can span the network. Well, in this particular case, what went wrong was that we have to inject a serializer definition from Akka streams in order for that to work. The very first time you materialize any Akka streams graph, that serializer definition gets added. Well, apparently that was not something that this particular user was doing. So we decided just to make the Akka Streams configuration built into your active system by default whenever you use Akka hosting, just to avoid that problem. At some point, I've wanted to do this. We should have like a scanning solution for trying to automatically load configuration values if they're there. That's something I'd like to do, but Akka hosting solution to this is probably the right tool for the job. Let's see. We updated the multi-node test adapter for users who are writing their own multi-node tests with Akka.NET. I ended up adding this. I was chasing ghosts, basically trying to fix some issues with, I think, Akka.Cluster Singleton. And it turned out basically that we had, well, actually, I guess it was a racy spec in the test suite I was looking at. Long story short, I added some enhancements to the multi-node test runner, basically to make it easier to kind of diagnose barrier issues and essentially getting cleaner telemetry on what's going wrong when things fail. So we added that to the Akka.Remote test kit, and we've incorporated that into the multi-node test adapter. So you'll want to update your references to both of those packages if you're doing multi-node tests. And then finally, we've got Akka.NET 1.5.28. Let me go and pull this up. So we have a litany of different fixes that all went into this. I think probably the most important ones are a couple of yours, Gregorius. There's this one
Mhm.
with the singleton proxy. There's mine with Akka.Persistence. And then let's see, I guess probably the actual Akka.Persistence changes and some of the bugs with the if you're trying to use stream references, Gregorius, you fixed a pretty nasty bug with the
Mhm.
serializer in there where it can have a first chance null reference exception, which just sucks to say the least when that happens. Normally, we never ran into this because Akka.Streams usually get started late in the Akka.NET lifecycle. Now that we're starting this up at launch in Akka.Hosting, we can discover that this is a problem a lot earlier, right? So that's been fixed. Gregorius, why don't you tell us a little bit about this issue, this cluster singleton proxy and the lease management stuff?
Mhm. Well, the big problem there is basically a flow problem. Uh, with proxy, it tries to look for a new singleton every time there's a change inside the cluster. But of course, if the lease is problematic, like if somehow it got deleted, there's no change in the cluster. So the proxy doesn't really look for a new singleton to talk to. So yeah, that's a really big bug.
So we've since fixed that. Now, if you're not familiar with Akka coordination, leases, a lease in Akka coordination is basically a distributed lock. This is a way of kind of hardening some of the data consistency, I guess data and application consistency in a distributed system. We have a bunch of different lease implementations. The user who reported this bug was using our Kubernetes definition. But the idea is that certain components in Akka.NET, such as cluster sharding and cluster singletons, can use leases to essentially negotiate who really is in charge of a given resource or a given decision-making process inside the system. We also, probably the biggest usage of lease is our split brain resolver. But in this particular instance, this was coming from cluster singletons and singleton proxies using it, and we were just not properly reacquiring leases in the event that something bad happened to them. Um,
Mhm.
so that's been fixed. That's a pretty significant bug fix. This is our other little 10-year-old bug that we fixed, which is that none of the snapshot metadata we've saved in the past decade across probably billions of snapshots has ever had a correct timestamp on it. Now we do. We use the datetime.utc now as the default timestamp going forward. This is going to allow us to properly support saving multiple snapshots at the same sequence number on platforms with stronger consistency, like SQL Server, for instance. This is one of the factors we wanted to use to be able to support that. Now, there's some nuance to how we're rolling this out, some of the different plugins. That's part of our ongoing sort of update cadence that Gregorius is working on right now. You should see some releases to all of the Akka.Persistence plugins kind of get sprinkled out over the next week or so here. And then let's see, we have some TCK specifications we added to fix that. I'm working on trying to make distributed data less aggressive in saving folders to your local system whenever you have remember entities enabled. That is something I'm currently working on because I personally found this to be very annoying while working in our test lab. So, eating our own dog food, trying to make Akka.NET's developer experience even better. So that kind of does it for our, let's say, what we've done since our last meeting. Future Akka.NET plans. So I'll go ahead and pull this up here. We are in the process of updating a whole bunch of the persistence plugins, like I mentioned. The big thing that I've been working on over the past, let's say, week or so is trying to prototype a replacement for .NETty using System.io.pipelines and a couple of other different, more modern .NET components. And I've actually had a chance to experiment with these ideas on TurboMqtt, which is something that we've been building on top of Akka.Streams primarily. So I'll pull this up real quick. Now, I don't have my unit tests passing reliably here, although the system generally does work. This experiment is in kind of a failed state at the moment. Let me go and pull up real briefly some of what we've been engineering here. Now, I basically took a lot of inspiration from ASP.NET's Kestrel transports for TCP for this stuff. Namely, one of the big things that we have when we're trying to work with transport layer security, which is, of course, a mandatory requirement that we need to preserve for Akka.Remote, is that the only real way in .NET to implement TLS safely right now is through using a construct that looks very old school called the SSL stream. The SSL stream is basically a wrapper on top of another underlying stream. And when I say stream, I mean, think of like System.io from like 2005. That's basically how this stuff is all built. It does support things like TLS 1.3 and all that are all supported, or whatever the most recent version is. That's all supported inside the SSL stream, but its API is very old school. So in order to actually work with transport layer security, we either have to expose our socket as a network stream, which is what I have done on not this pull request, but on this one, where we actually have full TLS implementation enabled here. And migrating our TCP sockets to use a network stream hurt quite a bit, which is we're doing like 190,000 requests per second here. We're doing like 300,000 using our System.Channels based design that we produced earlier. So that's like a 40% drop off in performance, even when you're not using TLS. This is just from redesigning our networking layer to use streams natively, so it's easy to support TLS. Therefore, one of the things that I wanted to try to do is do a little bit of what ASP.NET Core does, which is they basically spoof using a stream under the covers. They basically wrap a System.io.pipeline, a duplex pipeline. They go and wrap that inside a custom stream adapter and then have the TLS stream talk to that instead. This allows them to continue using essentially a pipelines oriented implementation for their high-speed, Kestrel transports, and without necessarily giving up on performance all that much. So that's a very useful type of design trade-off they've made there. So in our system, we attempted to migrate. These are some of the custom Akka.Stream stages that I've like forked a little bit in order to take advantage of System.io.pipelines. We're using a pipeline writer for the MQTT encoder. And then on the decoder, we are using a pipe reader. And basically, we use two different sets of pipes. We have a set of duplex pipes, one that basically reads to one set of pipes that is application output and transport. Application output is basically what gets routed to the end user. And then you have application input, which is data that we read from the transport. And then we have sort of the vice versa for the transport layer itself. It's basically a set of two different pipes that are kind of being basically shared in a somewhat duplex fashion between the application and the transport. So my initial results of this experiment that I kind of wrapped up this morning is that unfortunately, this is much more cantankerous to use than I would have initially expected. It's really clear to me, if you take a look at like the Kestrel source code, it's really clear to me that System.io.pipelines probably got extracted from it. It was definitely designed to work very closely with how ASP.NET is built. And there's certain parts of how it's designed that don't play very well with some of the constructs we had already built into TurboMqtt. A really simple example. If I go down to, let's find our decoder stage. Oh, we're actually on it. Great. If we go down to our decoder stage, we basically are reading from the pipeline. We have this async read operation right here. And when we get a result back, assuming that we haven't already completed everything, I probably need to move that down here, but whatever. We basically, if we want to go ahead and take a look at the data that's been read, it's a read-only sequence. A read-only sequence is essentially a non-contiguous region of memory. This is how they take multiple different bursts of memory that have been received over a socket, and they'll try to virtually lay them out consecutively into a sequence here. System.Memory, where we're using things like memory, read-only memory, span, all that stuff, that all requires contiguous memory access. Well, if you did what we did and we programmed our MQTT decoder and some of our other constructs to work with things like read-only memory or work with read-only span, all that sort of stuff, it takes a little bit of work and finagling to try to get read-only sequence to work correctly. Essentially, you have to iterate over it and pull multiple different pieces of memory out of it and manipulate each one individually. Now, there's some really powerful things you can do with read-only sequence and with like the sequence reader and so forth, but there's some constraints that come with that, such as you can't use the sequence reader, which is a little like kind of think of it like a stream reader, but for sequences that they built. You can't do that in methods where you're awaiting, for instance. The data structure doesn't support that. So there's all sorts of little constraints we kind of have to work around with some of this stuff. But that being said, so this experiment is kind of a bit of a failure on TurboMqtt. The reason being is that I think the performance is actually worse and the system is less reliable. So there's some tweaking that needs to be done here. However, what it's given me is a pretty good set of inspiration for what we can do with Akka.Remote. Now, forgive my lack of show preparation here, but let me go ahead and show you an example of a performance gain we're looking to try to get from basically getting rid of DotNetty. If you're not aware, .NETty is the underlying library that we've been using for a number of years. I really think since Akka.NET 1.2, we've been using .NETty. .NETty was originally built by the Azure IoT group to power their IoT hub, and I believe it's still used in the IoT hub client to this day. The project more or less got abandoned because that team switched to using Rust on the back end. That was at least what I recall Max saying at the time. So Max was basically the leader of the .NETty project. So if we take a look at our .NETty transport, let's see. Yep, sure thing. I'll go ahead and give JetBrains access to all the stuff behind the scenes here. I think I just did an update on it. I won't bother getting into, let's say, the .NETty code per se, but what I really want to see is the transport. Here we go. An example of, let's say, a really stupid area that creates overhead and we can't really get rid of it with the way .NETty is currently built is if I go down to, where is our association handle? Let me search for this. Actually, see handle. Create handle. This is the one I want to see. Let's take a look at that TCP association handle. Okay. So this is an Akka.Remote construct right here, this association handle. This is the actual component that the Akka.Remote endpoint actors use for sending data out over the wire. There's a couple of issues with the way .NETty works. The first and foremost issue that it has, if we take a look at the underlying design of, let's say, the handlers right here, well, let's take a look actually at one of these handlers that we use in .NETty. If I scroll up here, common handlers. Well, I think I'd have to dig a little deeper into the code to find some of that. But the long and the short of it is every single write operation, even if we're just writing a 1 byte long packet, generates a task completion source and a task that has to be basically essentially a task completion source that has to be completed every single time. In the original Java project called Netty, from which .NETty is derived, you have the ability to kind of dependency inject that promise, that task completion source in. And the way that library was built is the caller could put in like essentially a void promise, and that elides all of that code completely. So for every single packet that gets written out to .NETty today, we have to go and allocate a task completion source. Then we have to invoke it, and there's no one even listening to it. It's just waste that's happening inside the system. So that's something where if we got rid of that, I would expect to see the computational overhead of Akka.Remote decline significantly. The other problem that we have with .NETty is the way it services threads behind the scenes. .NETty has been essentially a bit of a resource hog from that standpoint. Now, I think in the new version that we updated to, in order to avoid that security issue you were working on back in June, Gregorius, I believe they redesigned some of this, but basically .NETty maintains its own distinct thread pool that is servicing all these IO events that are coming up. One of the things I believe we can do with an Akka.Streams plus a System.io.pipelines based design for Akka.Remote is essentially just run on the normal .NET thread pool. That way, we can use the hill climbing algorithm that's built into it to scale threads up and down. And this should further reduce Akka.NET's like idle CPU footprint, which is important for people who are running in low powered environments or in environments like Kubernetes, where you might densely pack a lot of resources together that are all running on the same hardware fundamentally. So these are some of our goals. We think we can basically reduce idle CPU and improve throughput with a little bit of elbow grease here. And we've been kind of prototyping some of our work and trying to really learn how to work with System.io.pipelines. We've been trying to do some of that on .TurboMqtt, since that's kind of a risk-free area for us to experiment. And we also do have an impending requirement to add TLS support there. So far, the results of the experiment have been, we've learned a lot, but we don't have a design that we are fully happy with there. We're going to take another crack at it and see about building a proper transport for Akka.Remote while we're at it. Gregorius, any questions or comments?
Yeah, well, the new .NET is actually slower than the old one.
Yes, it is by about 10% as a result of some of the changes they made. So that was kind of what motivated us exploring this in the first place. Is we hate giving up a free lunch, namely, especially to service a really stupid CVE that, like, you want to talk about compiler ceremony? That CVE reference was for what? The HTTP client, right? Which we don't even use inside Akka.NET. But because we happen to have a transitive dependency on it somehow, we kept getting flagged, and we, basically have to either explain to customers, hey, this isn't a real CVE, don't worry about it, we're not going to fix it because it's going to affect our downstream performance. And that's basically going to end up being a big waste of breath for us, because the sort of people who care about compliance on this stuff don't really want to be in a position where they have to give a word salad explanation for why this CVE is not a CVE each time. Our approach basically as an industry to security is fairly our approach as an industry to security is basically kind of all or nothing right now. I guess it's better to be safe than sorry when it comes to eliminating CVEs, but the idea that there's no trade-off there isn't real. That there definitely are trade-offs. So as a result of that, we're going to attempt to roll our own .NETty replacement. I personally will feel spiritually very satisfied that .NETty is dead and gone, because it's been a piece of abandonware for the better part of 5 years now. And I'll feel like this is technical debt that is now off of our hands if we do this. Plus, it'll be a good opportunity to get Akka.Streams a closer look at it from a performance standpoint, which is something that I've been keen to do as well. Let's see. Yep, Adam, hello to you too. Well, guys, thank you very much for your time today. Really appreciate it. I guess we'll go ahead and wrap up here, and we'll see you all for our October live stream. Thank you very much, and don't forget to give us a shout on Discord if there's anything you want us to get into for next month's Community Stand-Up. Thank you for your time. We appreciate it.